Hi, my name is Max Grafholner, and I am doing a PechaKucha presentation on 3D printing and the effects the emerging technology has had on the current manufacturing techniques, standards, and processes used in today's manufacturing industry. Let's get started. First, we must understand what is 3D printing, or additive manufacturing as some refer to it. 3D printing is the process of fusing successive layers of material upon each other, building up consistently into a 3D shape. How does 3D printing work? Three basic steps are material. You have a selection of materials coming in a spool somewhat like a weed whacker. You have CNC control that operates a gantry style XYZ coordinate plane. Then you have an extrusion head that pulls the material, forces it through a heated block, and then creates layers. What materials can be 3D printed? Right now the 3D printing industry divides into two categories, plastic and metal. Right now plastic is mainly a nylon type of component, while metal has a various array of options. There have been advancements in options like carbon fiber and wax as well. Where is 3D printing technology today? Currently on the technological S-curve, it has just surpassed the custom-built phase, and it's going into more of a product phase, where commercial entities and home users are buying printers for their own use and for design use. Now that we understand where 3D printing is technologically, we must understand where 3D printing is economically to size the industry. As you can see from the graph, in 2014, 3D printing was about a $5 billion revenue industry. By 2020, it is expected to progress to a $35 billion industry. Who currently utilizes 3D printing technology in today's economy? From the prior slide, you can remember that the industry is growing, but it's still in its infancy stage. As you can tell, some of the bigger companies are getting into this, with GE, Lockheed Martin, Ford, and HP leading the way. Some may ask, what is 3D printing most used for, other than making little gizmos and gadgets? Well, first, you have functional prototypes. So you have something like the bike helmet here where you can test fit and size. Then you have custom-made one-offs for custom and personalized ideas. And finally, like GE, you have final parts for aerospace. What are some common 3D industrial applications in use today? Right now, racing and aerospace lead the way in additive manufacturing. Both industries are looking for high strength, high complexity, and low production costs on all of their parts. They're looking for very specific geometries, and they're able to obtain this with 3D printing. There's also been a push for utilizing 3D technology in other industries. Right now, one of those that you might have heard in the news is biomedical industry, making prosthetics and things of that nature, as well as homes. There's a company in China right now that will 3D print you a home. A little rough around the edges, but it still looks good. Why do we care about 3D printing? What are some of its most important features? There's CAD to product importing. You can see from the computer screen model, the CAD model then printed exactly into the 3D printed object, as well as complex geometries become simple. You can take a look at the turbine disc, and it printed just as seen. Finally, as we just mentioned, there's low to no waste, meaning the material that is input is almost exactly the material of the product that you're going to be using. Second, the multi-part printing. You can now combine 3 or 4 of your parts that used to be assembled into one main design that's 3D printed together. 3D printer has the capability to alter the current process flow of traditional manufacturing design. Right now, there's about a 8 or 9 step process that currently is utilized to create a part for a problem. You can see that there's a lot of reiteration in the process, and one cycle may not be enough. 3D printing has the capability to considerably shorten the manufacturing design process by simply importing a CAD model into the 3D printer, printing the part, testing the part, adjusting the CAD model if need be, and reprinting again. It's a very short 3-part cycle. Now let's take a look at the future of 3D printing. I showed earlier projections for the economy of 3D printing, but if you take a look at past from 2012 to 2013, the number of units shipped doubled, It again doubled from 2013 to 2014. It's projected to double once again. You can see the rising trend. What's in store for 3D printing in the future? There's many different applications being tested right now in labs throughout the country and throughout the globe. Right now, NASA is developing a 3D printer to be sent to space to both create food such as pizza and parts for things like the space station for astronauts while they're in flight. The US government is looking into other future applications of 3D printing, such as sending a 3D printer over to a combat zone overseas, and then from there, an engineer can print or modify a piece of a gun or another similar component that needs repair. As you remember from earlier in the presentation, biomedical engineering has a strong push to utilize 3D printing in their industry. Their strong push comes from the capabilities to create individual custom prosthetics for people, such as the 83-year-old woman who received a 3D printed titanium jaw. There's one major concern regarding 3D printing today, and that is patent infringement issues. Anyone can 3D scan and 3D print a patent part today. This will lead to a rise in patent attorneys and patent engineers very specialized in the art of 3D printing in the future. In conclusion, 3D printing has the revolutionary capabilities to completely decimate industries like casting, because 3D printing can create highly complex, low-cost, repeatable, and autonomous parts, one after another.